Hello again. This is part 3 of the screencast dealing with Excel spreadsheets and analyzing cohort data. What we'll do today within this screencast is we'll look at the structure of the data, but we'll be calculating some formulas that will help us make sense of what we've got. So we've frozen the first row. That allows us to scroll through the data all the way to the end. And the end is row 403 is where the data concludes. So we say to ourselves, how do we count this data? How do we manipulate it? How do we do things with it? Well, alternate ID, as you notice, ends at 402, and it started at 1. So that tells us that there are 402 students within our entering cohort, which is helpful to us because it'll trigger the calculation of a few other statistics as well. So knowing that, Excel has an interesting function that I've already filled in, and that is to count. Now, if we look at column E, entry term, we see that all of the values for entry term are fall 2001. So we know that all of these students started that fall. So our task then is to use a function that's called countF. CountF a certain value. So I'm going to go up here to the formula bar, and I'm going to say that we're counting all of the contents between the range of row 1, column E, or column E, row 1, column E, 403. And we're counting that whole range, F. E2, E403 is equal to the criteria fall, and I'm going to type that exactly the way it appears in the cells, capital F-A-L-L, 2011. I'm going to put another quote, I'm going to end it with the parentheses, and it's going to return that 402. So we know that there are 402 cases, and we also know that because the alternate ID. The alternate ID was supplied because we didn't want to put social security numbers down. We didn't want to put any identifier that was hooked back to the student. So for the purpose of this example, we just simply numbered all of the students by their respective row. So now we know there are 402 total. And then we say low income status, yes or no, as indicated in the column. And we can use our countF function again from D2 this time, which is the adjacent column, to D403. And the criteria that we're selecting is whether or not it's a Y with an N paren. And when we do that, that returns 210. So that tells us that there are 210 low-income students of a total 402 total students, to which you can make your own formula where you're dividing simply the contents of 210, which is in cell D504, by the contents of cell E405, both of which you've calculated using the countF function. But simply all you're doing is a simple division, and you come up with 52.2%. So about half the students, a little bit more within this cohort exercise, are low income. Now, the countF function comes in very handy as well, because you can count the last term of attendance. And again, the first term of attendance was fall 2011. And so if a student were to leave the institution during that fall or at the end of that fall, they would be counted in this formula. And this formula is the same countF formula. And again, the parens But notice that I'm saying G $2 and G $403. The reason I'm doing the dollar sign is that locks the rows. That locks row 2, it locks row 403, and it gives it the range to look at. And now the criteria is, quote, fall 2011, quote, in parens. And when I do that, I see that 101 students left, or left during that fall or at the end of that fall, but that was the last time that they were at the institution. So, of the original 402, there's 101 that were no longer there after fall 2011, and I can do the math there. I can say, okay, equal sign, 101 divided by 402 gives me 25, more or less 0.251243781. I can convert that to a parentheses by asking to format the cell. I can convert that rather to a percentage by hitting Command 1 to pull up the format cells. And I'm going to go down here to percentage, hit that. I'm going to really only be interested in one decimal point because I'm not calculating a GPA. Tell the machine okay, and I find out then that 25.1% of the total number of students, 402, left either during or after the fall 2011. Last term GPA, that would be the last GPA that they earned before they left the institution for all students, makes use of another formula, another function, and that is called average. And to trigger that, we'd simply put equal sign average and then parentheses the data range that we've been working with has been row 2, column 403. So that I could also go back here and put a dollar sign in before the 2 and a dollar sign before the 403. And what that does is that locks those rows if I do future other formulas, as I'll show you in a minute. So there's the average, 2.40. Now, with Excel and with Word and most Office products, you can copy something by hitting Control-C, which I just did, and to paste it to the next cell, Control-V. Now, when I did that, I get the same exact formula, and the range didn't drop down one because I locked it using the dollar sign. I locked the rows 2 and 403. But this time, instead of using an average, let's say that you want to use another statistic. And let's say that you're interested in what the minimum GPA was. And when I type M, the drop-down menu comes up, IN, and I insert that, and I get 0.00. So there were students who left with a 0 point GPA. I can also copy this again, and let's paste it, Command V, or Control V if you're using a Windows machine. Instead of using minimum, let's look for something else that's a descriptive statistic. We know minimum, we know the maximum has to be 4.0 because that's a perfect grade point average, but let's try something like standard deviation. And we're going to see that we have a number of choices. We're going to use the simplest of those and say STDEV. And again, this formula is locking the range that we've used, which is H2 to H403, and I've gotten rid of the 2 parentheses that Excel so conveniently provided for me, which would return an error right after STDEV. And I get 1.26 is the standard deviation, meaning that there's a spread between the mean there, which is 2.40, And the first standard deviation, which would contain about 34% of the cases, would be 3.66. Going down the other way, subtracting 1.26 from 2.40 would yield 1.14, so that you get a sense of the spread. So that's it. You can use our COUNTF function to determine, as you'll see some of the questions that you have, how many entered math at college level. Well, to get at that, I would go down below my column, my last row, and I would say equal count, COUNTIF. And again, I want to use this column, which is S. And we know the first row with data is 2. We know that the last row with data is 403. So I'm going to type S403. And then I'm going to hit a comma, and I'm going to say equal N. And I don't want to use a small n, I want to use a big N, because that's the way the data are arrayed. And with an n parens. And I get 269 of the 402 students who did not enter math with college level. Because again, remember, I used N up here and not Y. If I would simply go back and correct that and substitute Y, and I want to know how many entered at college level, we'd see 133. And so here's my 133 that entered math at college level. I might also be interested in how many, or rather what percent, this 133 represents of entering students. Knowing that we had 402 entering students makes this calculation fairly straightforward. And again, we put an equal sign, and we can select the 133 because that's the value that is in S405, and divide it by our 402. And what we get is a percentage 33.1% of our total entering cohort that came to the college ready for college level math. Excel can perform some amazing functions for you. It's a tool that every senior leader should have in their toolkit. It can help you as you're looking to improve institutional performance, and it helps you enter into a dialogue with the people who can provide you the data, so that you're not waiting for them to do the work for you, but you have skills that will help you move through an Excel sheet and engage in institutional improvement at your level. That's it. Thank you very much.